So why is this always negative? Because, and you pretty much said it, not totally articulately, but you know, I think you've got it. But let's make sure. First of all, because this is less than gamma squared over 4m, and you said, because k and m are always positive, that's got to be, you didn't quite say it that elegantly, but who could ever be as elegant as me? Well, just about anybody, but, okay? Make sense? So the square root of this has got to be less than the square root of that. But what's the square root of this?
Gamma over 2 times the square root, or divided by the square root of m.
You know, I got a problem here.
Data is one way easier, but another way longer.
I've been leaving off the square on this m, right? I mean, in everything I wrote here. Never mind, no. Everything I wrote here. Okay? That m is squared. So I didn't write it there, and I didn't write it here. I think you said it. I'm thinking, well, why does I think that thing is squared? Well, because I kind of believed what I wrote rather than what I know. In taking the square root of this, I wasn't going to get what I needed to get.
Yeah, that's kind of where I couldn't figure it out. Because if that would just be m, your proof would fall apart, right?
Yeah. Well, none of this would be worth anything. Okay. So again, I was careless. Okay. So anyhow, you see that it's easy now to show, now that I've got it right, that this is correct. Okay? So why does this show that this is always negative?
It just does. You can take out the middle inequality.
Well, just algebraically, we get an airtight argument if we do this. Okay, we've got this, right? Well, that's got to be less than negative gamma over 2m plus gamma over 2m, right? I mean, this is less than gamma over 2m, which is established, right? Now this is the same here as it is here, and this is less than this, so this has to be less than this, right? And of course, this is equal to 0. So just to state everything that's really obvious, there we have it. So there's an airtight argument. It can easily be checked because every statement has been justified. Okay? That's how you prove something like this algebraically. Okay? Now it's pretty obvious. You just look at it and you say, square root of this is this, and this is less, so this can't be big enough to make that positive, right? To make the sum positive. Okay? And that's really pretty obvious when you look at it after you've seen it once. Okay? And if your algebra is good enough, your ability to look at expressions and understand what they're telling you is good enough, and that's a work in progress, okay? You're still a sophomore, you get away with a little sloppiness. Just get over it before September, or late August. Now seriously, you know, with experience, you learn to look for and find those things. Okay? So, what's this tell us now? This tells us that we have two exponential functions here. Okay? In our solution set, which means we have a linear combination of these two exponential functions. So let's see what that kind of looks like.